Every galaxy in the universe is held together by something we cannot see. Stars orbit, gas swirls, entire galactic structures hold their shape, all because of an invisible scaffolding of matter that outweighs everything visible by more than 5 to 1. We call it dark matter. We have never directly seen it, never captured a single particle of it in a laboratory, and for nearly a century, it has remained one of the biggest open questions in physics. But in the last year, several discoveries have arrived at once, and together they suggest dark matter may be far stranger than the simple, invisible glue we imagined it to be. The first sign came from somewhere unexpected. A handful of small, faint galaxies that appear to be missing dark matter almost entirely. The first one, called DF2, was discovered a few years ago, and its stars were moving so slowly that there seemed to be almost no extra invisible mass pulling on them at all. At first, scientists assumed it was a measurement error because every galaxy is supposed to form inside a halo of dark matter, the invisible mass that draws gas together in the first place and lets stars ignite. A galaxy without one seemed almost impossible. Then came DF4, then FCC 224, found in a completely different region of the sky. Then in 2226, a fourth galaxy called DF9. 4 separate galaxies in different locations, all showing the same strange signature, stars moving as if there is nothing extra there to pull on them. Individually, any one of these could be dismissed as an unusual case. 4 of them, appearing independently, is much harder to explain away. Some astronomers now believe these represent an entirely new class of object, dwarf galaxies built almost entirely from ordinary matter with little to no dark matter at all, a possibility nobody expected the universe to allow. If galaxies can form without dark matter, that alone forces a rethink of how fundamental a role it actually plays. But the surprises did not stop there. For decades, the standard model assumed dark matter was cold, meaning it moves slowly when it first formed, drifting gently into place under gravity. That assumption sits at the foundation of nearly every simulation of how the universe's structure came together. In January 2026, researchers at the University of Minnesota and a French university proposed something that challenges that assumption directly. Their calculations suggest dark matter may have been born hot, moving at nearly the speed of light in its earliest moments, only cooling down later, fast enough to still explain how galaxies eventually formed. It sounds like a small technical detail. It is not. It changes the entire timeline of how the earliest structures in the universe came together. Then in November 2025 came something that may be the closest anyone has ever gotten to actually seeing the thing itself. A researcher at the University of Tokyo studying data from NASA's Fermi Gamma Ray Space Telescope found a faint halo of high-energy gamma rays surrounding our galaxy, matching almost exactly what theory predicts should appear when dark matter particles collide and destroy each other. Nearly 100 years after dark matter was first proposed to explain the strange motion of galaxies, this is one of the strongest direct hints yet that we may finally be catching a glimpse of it. And there is one more thread, perhaps the strangest of all. In October 2025, James Webb Space Telescope observations hinted that the very first stars in the universe may not have been ordinary stars at all, but something scientists are calling supermassive dark stars. Enormous objects powered not by nuclear fusion, the way every star we know burns, but potentially by the annihilation of dark matter particles at their core. If confirmed, it would mean dark matter did not just shape where galaxies formed. It may have lit the very first stars. Taken together, these findings point toward a picture of dark matter that is far more complex than a single invisible substance quietly holding galaxies in place. It may come in more than one form. It may have shaped structure differently than we assumed. It may be leaving faint traces in gamma rays right now above our own galaxy, waiting to be confirmed. And in a handful of tiny galaxies scattered across the sky, it may simply not be there at all. Nearly a century of searching, and the closer we look, the less dark matter resembles the simple story we were told, and the more it looks like one of the last great mysteries written into the fabric of everything that exists. What do you think? Is dark matter one substance we haven't found yet, or several different things we've been lumping together this whole time? Let me know in the comments. Subscribe because next time we are covering dark energy, the far stranger force pushing the entire universe apart, and why some of the newest data suggests it may not be constant at all.